first take our look at the calendar. So happy Friday. Today is our 16th class. It is our third and final day on transformations of functions. Next class, we're doing a supplement on linear regression. Supplement just means it's not like in your textbook, so we'll have lots of resources in the packet here that we'll go over. Coming up, quiz number 2 is going to be, I think that's the, is that the assigned date or the due date? That's the due date right there. So I'm going to hand you quiz number 2 in Monday's class, and you will take it home and work on it and hand it back to me on Wednesday. Okay? The quiz is on classes 11 through 16. So that is from the test until what we finish up today. It's a take home, and again, you're going to be able to use the same resources you used the first time around on that quiz. So I think that means lots of resources. So you don't need to go or like out of your way to study for the quiz. Like it's not an in-class thing. So anyway, that's coming up next week. Hopefully we're working on the projects, but that's again not due for a little while. But if you get it done early, it's one less thing to worry about later on. Questions on the calendar? Okay, and let's jump in here on 52. So the equation that we were interested in for this guy, I'll just copy it here, was g of x equals 3 times f of 2x. And so we're starting hopefully to really get a good sense of what the 3 does, what the 2 does, and then today we'll summarize everything, including like additions and subtractions. What does that 3 do? Does that affect the x or the y? It affects the y, and does it make it smaller or bigger? It makes it bigger by a factor of 3. And so you can see I've written here in blue, we're going to triple all the y's. So whatever the y coordinates were before, they'll get tripled. The 2, does that affect the x or the y? That's the x. It's inside the function, right? It's firmly next to the x. So it affects the x. This is a really common sticky point. It feels like the x's get doubled. After all, it says 2x, double x, right? But what's the actual effect on the x? They all get divided by 2. They become half of what they were. It's kind of counterintuitive, but I'm hoping we can get you to the point where it actually is not counterintuitive. We know, for example, that f, let's pick the point 4 here. How much is f of 4, looking at the graph? F of 4 is 5, right? That's just this point right up here. It says f of 4 is 5. When x is 4, the y is 5. So f of 4 is 5 is something that we know. We also know that whatever number we plug in here for x is going to get doubled inside of that function, right? Whatever you put in for the x is going to get doubled before the f comes into play. So if I want to put a number in for x so that this thing inside of my f function is 4, right? I'm trying to put a number in so that I still get 4 in the parentheses. Given that the x is about to get doubled, what x do we need to put in? We need to put in a 2, right? G of 2 is 3 times f of 2 times 2, that 2, and that's really saying 3 times f of 4. And right now I'm back to the same f of 4 point. This is the transformation of that point f of 4. And so, you know, like even though it says 2x, that 2 is going to double something. So if we want to undo it, then we better take half of our number to start with because it's going to get doubled before the f function comes into play. Okay, so here's the other thing I want to say about this is that, you know, the times 3, it's really intuitive for folks to say triple the y's, and then the 2 is the counterintuitive part. And so when I was a student, I learned that anything associated with the x's is the opposite of what you'd expect. And so, for example, if we saw this, naturally I want to say this is to the right 7. You say add 7 to the x's, that's going to the right. But really it's opposite. This is a left 7. Whereas if that 7 is on the outside, it is quite intuitive. That plus 7 means, yep, you're going up 7. Plus up, that jives. And so when I first learned this, it was just taught to me, hey, anything associated with the x is backwards from what you think. When you see this x plus 7, it's backwards. It's not right 7, it's left 7. When you see this x times 2, it's backwards. It's not times 2, it's divide by 2. And I taught it that way for a number of years. But fairly recently, a colleague of mine from a previous school told me that actually it isn't just backwards for the x's. It's backward for both the x's and the y's. And I mentioned this a couple of classes ago, that the only reason, I'll write it this way, the only reason that plus 7 feels intuitive is because we put the plus 7 on the wrong side. We sort of artificially get the y by itself. But really, it's the same as this equation, right? These are equivalent statements. It still means up 7. If it meant up 7 before, it still means up 7. So y minus 7 means up 7. It's counterintuitive for the y's, right? Subtract 7 to me on the y's would indicate down, but really it's up, as long as we don't artificially shove the 7 on the other side. And so it's the same thing inside the formula. It's opposite what I think it should be. I think that should be to the right 7, but really it's to the left 7. But the idea here is it's consistently opposite, right? It's opposite for both. And the same thing is true for the multiplication. Suppose that we write this. Again, what does that 3 do? Yeah, it does multiply. So is that a vertical or horizontal thing? Vertical, stretch or compress? Stretch by a factor of 3, right? But then somehow, you know, when we put the 3 inside, it's not a stretch, that's a compression. Everybody becomes a third of what they used to be, just like they were a half of what they used to be. Okay, here's what's going on. This 3, I could just as well put it over with the y, yeah? What does it become when I move it to the left? Y over 3, right? Not subtract, but divide. Okay, if I tell you divide the y's by 3, you probably think compress. But you know that this first equation is a stretch by 3. That's the intuitive part, right? So again, this y divided by 3, it is counterintuitive, but it is consistently counterintuitive across the board. You tell me the y's get divided by 3, it's actually a stretch. Over here, you tell me the x's get multiplied by 3, it's a compression, it's consistent. One last thing I can say. If I want this guy to be x over something, because apparently y over something is sort of natural, what is this x over? It's not 3. If it's going to be still equal to 3x, 1 over 3. You guys buy that? That 3x is exactly the same as x over a third, because you know when you divide, you can make it multiplication and then the reciprocal. So the two highlighted things are exactly the same, right? Okay, so then here's the way we should really be thinking about this. I'm not saying this is the way it's been taught. It hasn't been taught this way in your packet so far. But don't think of it as a 3 times x. Think of it as an x over a third. What did that 3x do to all the x values? That's what I wanted to do, but that's not what it does. 3x, what does it do to the x values? It compresses them. Each gets multiplied by what number? By 1/3, right? Hey, there's a 1/3 right there. So if you just write it as a divide, then all of the x's get multiplied by whatever number is down there. Super. Multiply all your x's by a third. That's what it says. What do we do here? Multiply all the y's by 3. That's the number that's sitting down there. So if we just force everything to be x over or y over, then it's completely consistent and it's completely intuitive, but we oftentimes don't do that. Right? Like the presentation in the packet matches the presentation in the book. And so we make it seem like there's no symmetry. The x's and the y's behave completely different from each other. Just trust me, that's how it works. There's total symmetry. We're just not doing it the right way. All right, let's go back a couple of pages here and make sure we all have the same answers on this very long class activity, 47. So this was the activity where I said I knew it was really long and a bunch of folks didn't have time to finish in class. I don't know if people had a chance to finish between class and now. Either way, let's all make sure we got the right answers in here, because this is a good summary for you to have on one page. C times f of x stretches or shrinks f of x. So as I say, vertical or a horizontal thing. That's a vertical thing. I'm too lazy. I'm just going to circle vertically. If c is greater than 1, it is a vertical, which one? It is a vertical stretch. By multiplying each of the y coordinates by a factor of what number? C. That's the magic number. Yeah, Pete. Oh no, maybe it should be like two separate thoughts. It's like it's going to be a stretch or a shrink, and to decide if it's a stretch or a shrink, you have to compare the number C to 1. If C is greater than 1, it is a stretch. If C is between 0 and 1, it is a shrink. By multiplying each of the y coordinates by a factor of, is it 1 over C? Got to remember, C is between 0 and 1. I mean, it's the same. It's the same C, you know, but I'll just put an example here. Like C might have been a half to start with, and you would look at that and say, oh, it's a half. It's a shrink by a factor of a half. Everybody gets multiplied by half. Okay. If C is negative, then the graph of f of x is what? What do we do? Putting a negative in the front, what does it do? Yes, graph of this is a reflection over what line? Over the x-axis. That's good. Make all the y values the opposite sign. You're flipping over the x-axis. Okay, and then the next piece here is related to this brand new function f of cx. Now the c is inside the function. Pre-operation is what we've been calling it. Is that a vertical or horizontal thing? That's a horizontal thing. We're inside the function. If c is greater than 1, this is the part that I'm not thrilled with. What's the answer? Is it a stretch or a shrink? It's a shrink. I'm not thrilled. It's just the right answer. I'm not thrilled with that because up above when c was bigger than 1, what was it? It was a stretch. It's because we messed things up artificially. That's why it's not the same answer. So with apologies, this one is a shrink if c is bigger than 1. And we divide each of the x coordinates by, so yeah, we got to be careful here. We got two blanks here, or multiplying each of the x coordinates by a factor of. Yeah, so you could either divide by c or multiply by 1 over c. All right, but if c is already between 0 and 1, then it is a stretch. And you divide each of the, all right, so this is tricky now. So let's make up a number. We're in the 0 to 1 case. If I'm talking about stretching, then let's do the bottom one first. Multiply each number by, should I multiply by c to make them bigger? Multiply x coordinates by this guy, that'll make them smaller. What do we need to multiply by? Anybody? What would you multiply by? Like, multiply by 2, which is 1 over, isn't it? Multiply each of the x coordinates by a factor of 1 over c, which is exactly the same as dividing each of the x coordinates by c. I know I've been complaining, but at the very least, we do have some consistency here, right? It is always consistently divide by c or multiply by 1 over c. Makes no difference whether it's a shrink or a stretch. It's the same answer, same process either way. Okay, and then if c is negative, then the graph of f is, let's see, so it's another reflection, right? Reflection over what line? Good, a reflection over the y-axis. Okay, so once you got all the answers filled in, let's jump back to whatever page we were on before, 53-ish. Yeah. Okay, and one thing that I like about this kind of question here, where we just give you a function but no formula, right? I didn't say this is the function x squared, and I didn't say this is the function square root of x. I just said here's a function, and it's pictured. It means that like you can't use the graphing calculator to just type in, oh, here's the transformation. Like you could just type in 3 times the function evaluated at 2x if you knew what the function was. So you really have to know your stuff in order to handle this thing, like regardless of what technology you have in your hands. Okay, so on the next page here, 53, I think, is another summary. It's kind of a different summary and sort of bringing everything together. The page we just filled in was only about stretches and compressions, but here we're going to have stretches and compressions and shifts. And so ultimately looking at this monstrosity right here, g of x is a times f of b times x plus c, and then a plus d at the very end. Okay, so it wants to know which of the constants move the function. That is to say, shift left, right, or shift up, down. Not talking stretches right now. C and D are the two. Those are the movers. Next question says, which of the constants change the shape? And those are the stretch compressions in both directions. A and B is good. Those are the multiplier guys. And now a different question. We want to know which of those 4 letters, A, B, C, D, affect the graph horizontally. So horizontal stretches and compressions, horizontal shifts. Which 2 letters are the horizontal letters? B and C, the ones that are inside of the function, right? B and C both live inside of our function f. Which of the constants affect the graph vertically? Must be the other 2 letters, but take a look. How can you tell that those are the ones? Because they're outside the function. A and D. Okay, and then it says compare the effects of the constants that change the graph horizontally and those that change the graph vertically. I'm not sure what that means. So let's go to the box. Number 2. To do transformations, you must first change the shape of the graph, both vertically and horizontally, and then shift or move it. So this is the first time we're thinking about doing maybe multiple transformations where you have to pay attention to the order. Could you imagine that, like, if I, imagine a graph, and then, like, let's say the first thing I do, you take your graph and you just shift it 3 units to the right. And then you stretch it horizontally, right? Okay, but now imagine I do the same thing in the other order. I take it, I stretch it horizontally, and then I move it 3 units to the right. It's not always going to be exactly the same picture. And so the order in which we apply these things affects the final product. And there's only one correct final graph, given that we're trying to graph this thing in yellow. So we got to get the order right. And this thing in the box is telling you what the order is. Do all the shape changers before you do any of the shifting. Okay, and then one final word of caution here. It says ignore the books and also MyMathLab's directions. They're on the top of page 280 for the order of how to do multiple transformations. What we want is the thing that's up here in the box. That is, those are the directions we're going to follow. In MyMathLab, I don't know if it'll be exactly the same letters, but you might see something like this. A times f of bx plus c plus d. What's the difference? No parentheses on the inside. And so really the only difference, it's a really subtle thing. If you distribute the b, which you're perfectly welcome to do, what do you get? Bx plus bc is the only difference between, like, what I have here. I have a c and they would have a bc. But whether or not this magic number b is factored out, like in the highlighted version, or distributed, like in the unhighlighted version, affects how you interpret the horizontal stretches and compressions. And so the book is going to tell you true things, but it's not going to be the way that we present the material here. And so you're going to ignore that little part of the directions. For every one of the examples that I give you, both here in the packet and on quizzes and on tests, the number will be factored out. See that 1/4 with parentheses? That means you can treat it the way that we just described. You could treat that 1/4. But if the 1/4 is distributed, then the rules change a little bit. can still do it, but it's not the way we're going to do it. Okay. All right. So this stuff is tricky. Take your time as you work through the activity and raise a flag if I can help.